Hello, welcome to another episode of SVA Design. In this episode, I'm going to explain to you how to determine what your compression ratio of the engine is if you're designing an engine, and I also want to explain how to make the ports for the air intake and also the exhaust port. So to start off with just the explanation of how to determine what your compression ratio is, let's use a section view of this surface right here of the cylinder that where we are right now. And to determine what your compression ratio is, all you gotta do is from the bottom dead center, measure this volume that's in the cylinder right now, so that in this case it's about 75 millimeters to the top of this surface, divided by this surface of the piston. And if we move the cylinder back to its top dead position, of this, so the volume that's above the piston from the bottom dead center to the volume that's above the piston from its top dead center as it is right now. If you divide the two between it, if you divide the two to each other, then we would come up with something like 75 divided by about 6 or 7 in my case. So that would end up with a compression ratio of about 14-15. The usual compression ratio for road-going cars is about 8:1 to 10:1. These compression ratios were good with the type of petrol that we use around the world, and it makes sure that the temperature of the air mixture with fuel doesn't get to a certain pressure or a certain temperature that would ignite the mixture prematurely. So that's also one of the risks with a higher compression ratio. With a higher compression ratio, the air to fuel mixture in the cylinder will also get to a way higher temperature and to a way higher pressure, and this could cause for premature ignition. So to prevent that from happening, you have to use a better fuel. So that's one of the disadvantages. But one of the advantages is that higher pressure and higher temperature means that the piston is pushed down with more energy, and this energy causes for the engine to produce more power with the same amount of fuel, so the engine becomes more efficient. I will also leave a link in the description with a couple of videos that explain this a little bit further. And yeah, that's about it. And I now want to start with building the rest of the cylinder head. So right click the cylinder head and go to open part. And as you can see on the left side of the screen, I already made like a bunch of sketches because I thought I was recording, but it wasn't really recording. So I'm just going to explain to you what I basically did and yeah, how to do it. So start off with these 3 sketches. So select this plane, click on sketch, and make a circle from the center of this line right here. And in my case, this circle I believe has a radius of about 30 millimeters. And let's check if I'm correct. Yep, that's the radius. And you can exit the sketch once you did that, and then you can go to 3D sketch and make 4 lines right here. And the way that I made these 4 lines is just make a line that goes from this point to this point, and then just make sure that the line is as smooth as possible, and that the air doesn't really have a lot of obstacles and doesn't hit into walls or anything once it's flown to the port. And once you did that and you have those sketches laid out, you can go to Loft Boss and select this circle right here, and also select the circle right here, and use all of the guidelines to guide the loft between the two, so make sure that it's as smooth as possible. Once you did that, we can now go to the next 3 sketches and show them. You basically do the same thing, but the sketches become a little bit smaller. So as you can see, we have this circle that is 3 millimeters smaller in radius than the outer circle that we made, and that's also the case with this circle right here. And we also made lines that connect to about the same points but are the inner lines. So what you basically do to do that is open this line right here so it's not hidden or anything, and then just make a new sketch and make sure that those lines are as similar as possible. If you don't then do that, then the cut would interfere with the outer wall and it would have holes in it and everything, and air wouldn't be able to flow through to the best of its ability. So once you did that and everything checks out to be correct, you can select this line right here and also select this circle right there, and then use all the inner guidelines that we just made. And this was the type of interference that I was talking about. As you can see, this yellow surface right here, that means that if I would click on OK right now, that would be a hole right here. So that's why we got these guidelines right here, and as you can see, it's gone now. And the last thing we need to do is make sure that this hole is free. So make a sketch from that I already made that sketch. So just select the sketch and click on cut extrude. And as you can see, the hole is free right now. So do the same on the other side. So select make a circle that from the center right here, from the center of this line right here, it has about a 25mm radius, and again on this surface right here, make a circle that is about 3mm bigger than the circle of the valve board right here. And do the same thing with the guidelines again to try to make it as smooth as possible. And once you got that down pat, then select this surface, select the sketch, and also select this circle right here, and then just use the guidelines to make sure that everything functions correctly. And we also need to make the holes for the exhaust part, so let's do that. And it's basically the same what we did right here. So make another set of lines again that also follow the guidelines of the outer walls to make sure that there are no holes or nothing. And the last thing we're going to do is make sure that everything is flat on this surface so that we can mirror everything. So just make a rectangular shape that encircles everything, that surrounds everything, and then use the cut extrude so to cut everything out that we don't need. And as you can see, we end up with something that looks a bit like this, and from this surface we can mirror everything. And this is what we would end up with. And once you go back to the engine, you can now see that the air intake port is a lot bigger, and it's also the one that's on top, and the exhaust air port is a little bit smaller. So the last thing I want to discuss in this episode is not only do I use the free valve technology, I also wanted to combine it with two spark plugs, so that we have a spark plug that comes in right here, and we also have a spark plug that comes in right here, and direct fuel injection that would come in the center of the cylinder, not just really quite the center of the center, but somewhere around here. And with this technology, we could use like cylinder deactivation. So if you're just on the highway cruising at about 60 miles an hour or 100 kilometers an hour, depending on where you are in the world, you can have a cylinder deactivation, which allows you to only run on 4 cylinders instead of the 8 cylinders, so you can get great fuel mileage, and when you wanted to, also great power, because the engine is very efficient, and if you use all these technologies in the right manner. So that's basically it for this episode. I want to thank you for watching. If you like the videos, please leave a like, subscribe. Also follow me on Twitter at SVA Design, and I'll see you guys in the next episode.